What if you could literally bottle a planet? I know it sounds like science fiction, but today we're diving into a remarkable piece of tech that does pretty much just that. It forges alien atmospheres right here in a lab to unlock the secrets of worlds light years away.
I mean, think about it. It is a huge challenge, right? When our best telescopes peer out at distant planets, they often just see these hazy skies, maybe some strange colors. So how do you figure out what's actually in that air, billions of kilometers away, without having to send a probe every single time? Well, that's the exact mystery we're going to solve today.
All right, so here's our game plan. We'll start with the planet in a bottle itself. Then we'll get into how it actually forges these alien atmospheres, how that helps us read the skies, and this is the cool part. We'll uncover its surprising impact on tech right here on Earth. And finally, we'll see how it all comes together to create a kind of chemical dictionary for the entire universe.
So let's get right to it and meet the star of our show. This is a machine that is totally changing how we explore the cosmos, all without ever leaving the ground.
Meet SARA. That's short for Simulateur d'Atmosphères Planétaires. It's a photochemical reactor based at a lab in France, and it is, for all intents and purposes, our planet in a bottle. Inside this machine, scientists can perfectly recreate the conditions of far-off worlds. They can dial in the pressure, the temperature, the energy from a star, and then just sit back and watch an alien atmosphere get built from scratch.
So what is SARA actually creating in there? Well, a key ingredient is something called tholins. Now, these are complex, sticky, organic particles that form when you take simple gases and just zap them with energy, like UV light from a star. They create this thick orange smog. You've probably seen it in pictures of Saturn's moon Titan. And here's why that's so exciting. These organic molecules are thought to be a potential first step on the road to life.
Okay, so how does it actually work? I mean, how in the world did you forge an alien atmosphere inside a steel chamber?
The whole process is actually pretty elegant. First, scientists pump a very specific mix of gases into the chamber, say nitrogen and methane to copy Titan's air. Second, they use a radio frequency to ignite a cold plasma, which basically acts like a miniature star, blasting the gas with energy. And finally, that energy rips the gas molecules apart, and they recombine into more complex molecules and those hazy tholin particles. And bam, you've just forged an atmosphere.
You know, here's a perfect way to think about it. The scientists who work on SARA often compare the tholins to big city smog. But the key difference, of course, is that this is cosmic smog, formed by the fundamental building blocks of the universe, not a bunch of traffic jams.
But why go to all this trouble, right? Why build this whole machine just to create some cosmic haze? It's because SARA acts as our translator. It helps us understand what our most powerful telescopes, like the James Webb, are actually seeing when they look out into the cosmos.
And SARA's versatility is just incredible. On one hand, it can simulate the freezing, dense atmosphere of Titan, which scientists are obsessed with because they see it as this giant prebiotic factory, a world where the building blocks of life might be cooking up right now. But on the other hand, SARA can simulate the complete opposite, the scorching hot air of exoplanets, like hot Jupiters. By creating all these different atmospheres in the lab, SARA gives us a reference library, a kind of chemical fingerprint that helps us finally make sense of those faint signals our telescopes are picking up from light years away.
And its work on Titan alone has been, well, nothing short of revolutionary. Thanks to SARA, we now understand how nitrogen, which is absolutely essential for life, gets woven into organic molecules way up in Titan's atmosphere. This is the research that finally explained that iconic orange haze the Cassini probe saw, and now it's helping us predict what NASA's Dragonfly drone is going to find when it finally lands there in the 2030s.
All right, now for the big twist. You might be thinking this is all about distant alien worlds, but the fundamental science happening inside SARA has some incredibly important and surprising applications right here on Earth.
The connections here are just fascinating. The same principles used to model Titan's haze, they help us create better models for air pollution right here. Understanding how these particles react with UV light can lead to more efficient solar cells. But the most surprising link of all is how this cosmic chemistry connects directly to the computer chip inside whatever device you're using.
It sounds crazy, but it's absolutely true. That cold plasma process SARA uses to simulate cosmic haze, it is the exact same technology used to etch the microscopic circuits onto computer chips. So yeah, the research into alien smog is directly helping build the very device you're watching this on. How wild is that?
And this research really does point to the future. By understanding how these unwanted particles form in plasma, engineers can make cleaner, faster computer chips. It's also paving the way for a kind of green chemistry, where we can use plasma instead of harsh liquid chemicals in industry. And looking even further ahead, this is the kind of tech that's key for our future in space, learning how to turn the atmospheres of Mars or Titan into breathable air, water, and even rocket fuel.
So after this whole journey, from a lab in France all the way to the moons of Saturn and beyond, what's the big takeaway from our little planet in a bottle? It all really comes down to this one simple, beautiful idea. The laws of chemistry are universal. The way that energy breaks down simple molecules and rebuilds them into something more complex and interesting, that happens the same way everywhere. SARA is the ultimate proof that the processes we can control right here in a lab are the very same ones shaping worlds all across our galaxy.
And that is what makes this so incredibly powerful. SARA is so much more than a simulator. You can think of it as the dictionary we're writing. The dictionary that lets us translate the light from distant stars, read the chemical language of the cosmos, and maybe, just maybe, find a story out there that looks a little bit like our own.